What is coefficient of linear correlation? Basically, it is used to measure the strength of linear relationship between two variables, dependent variable and independent variable. The coefficient of linear correlation standardizes the measure of dependency and allow us to compare the relative strength of dependency of different set of data. It is also commonly called Pearson product moment, which is represented by letter R.
So, how do we interpret a correlation coefficient value? The correlation coefficient value ranges from -1 to +1. So, this is the positive correlation. A change in the value of positive correlation will predict a change in the same direction of the second variable. A coefficient of -1 indicates a perfect negative correlation. A change in one of the variable value will change another value in opposite direction. A coefficient of 0 indicates that there is no discernible relationship between the fluctuations of the variable. This means that there is no relationship between the variables.
An agriculture research organization tested a particular chemical fertilizer to investigate the relationship between an increase in the amount of fertilizer used and would lead to a corresponding increase in the food supply. So, calculate the person's product moment correlation coefficient, which is represented by R. Explain the result. N is equals to 7. N is the number of data. Next, total of X, which is equals to 20. Total of Y, which is equals to 30. Next, total of X squared, which is equals to 68. Next, total of Y squared, square of the Y, which is equals to 136. Next, total of X times Y, which is equals to 93. So we moved to the second step, which is the strength of the linear relationship of X times Y, which use the formula of total of xy is minus with total of x times total of y divided by the number of data. Use the value that we have find before, which is 93 minus by 20 times 30 divided by 7, which is equal to 7.2857. Next, find the SS for x, which is equals to total of x squared minus with total x squared divided by number of data. Use the value that we have found before, which is 68 minus by 20 times 20 over 7. Use the calculator. And the answer would be 10.8571. Okay, next. Find the SS for y, which use the formula of total y squared minus with total y squared over n. Use the number that we have find before, value, which is 136 minus 30 times 30 over 7. Use the calculator and you will get the answer 7.5 4286. And then to find the R, use the formula of S as x times y over square root of SSX times SSY. So substitute the value that we have find on the previous calculation. 7.2856 over square root of 10.8571 times with 4286. So use the calculator and the answer would be 0.8110. So that's the final answer.